Hello, Mr. Wright here, and welcome to this film on similarity, on similar shapes. And in this film, I will walk you through 10 IGCSE questions on similarity. These questions involve finding linear measurements, surface areas and volumes of similar shapes using linear scale factors, area scale factors, and volume scale factors. You can download the questions and have a go at them first by hitting the link in the description, and then you can watch me work my way through the questions, or you can download the questions and work alongside me watching the film as you tackle the questions. Entirely up to you. If you've got any questions, please do leave them in the comments, and of course I'll respond, or leave me a comment anyway and tell me how you're getting on. If you're preparing for your Edexcel IGCSE Maths, why not subscribe to the channel? There's lots there to help you out. Right, let's get on with the maths. Question 1. Right, we have two vases, A and B, and we're told their volume. So the volume of A is 405, and the volume of B is 960. So I can work out that volume scale factor by doing 960 divided by 405. So the volume scale factor is 64 over 27. Right, well that will help me work out the linear scale factor, because it's going to be the cube root of the volume scale factor. So if I cube root the volume scale factor, I get 4 over 3, so that's the linear scale factor. So now I know the area scale factor, which is the square of 4 over 3, the square of the linear scale factor. So that's going to be 16 over 9. Now let's have a look at the question. B has a surface area of 928. Work out the surface area of A. So I need to know the surface area of A. So 928 divided by 16 over 9. So that's going to be 928 divided by 16 over 9 gives me an answer of 522 square centimetres. Question 2. I'm given R and S, two similar shapes. Shape R has a surface area of 108 and a volume of 135, and shape S has a surface area of 300. Right, well I can work out the area scale factor. 300 divided by 108 is 25 over 9. So from that I can work out the linear scale factor by square rooting 25 over 9. And so from the linear now I can work out the volume scale factor by cubing 5 over 3. So that's 125 over 27. So now I'm being told the volume of R is 135, and I'm being asked to work out the volume of S. So the volume of S will be 135 multiplied by that volume scale factor. 135 times 127 over 27 gives me an answer of 635 cubic centimetres. Question 3. I've got two regular pentagons, and I'm told that EJ, which is this length here, is 4 times AE. Right, now be careful with this, because if, for instance, AE is 1, then EJ is 4, but importantly, the whole of that length would be 5. So the linear scale factor between the small and the large pentagons is 5, because the side length of the large pentagon is 5 times the side length of the small pentagon. Right, once I've got the linear scale factor, I can work out the area scale factor between the two pentagons will be 25. So it tells me here that the area of the smaller pentagon is 8, So the area of the larger pentagon is 8 times 25, 200. Now, does that answer the question? Well, it doesn't, because the question is calculate the area of the shaded region. Okay, well, the area of the shaded region is the area of the large large pentagon, 200, minus the area of the small pentagon, 8. So the area of the shaded region is 192 square centimeters. Question 4. A and B are two similar vases. Okay, A, B, linear, 24 the height of A, 36 for the height of B. So the scale factor is 1.5. Vase A has a surface area of 960. Work out the surface area of vase B. Well, if the linear scale factor is 1.5, then the area scale factor is 1.5 squared, 9/4. So to work out the surface area of vase B, I'm simply going to do 960, the surface area of vase A, multiplied by the scale factor, giving me an answer of 2,160 square centimeters for the surface area of vase B. All right, now let's have a look at this next question here. Vase B has a volume of 3. Right, so I'm going to add volume here. And vase B has a volume of V. Find in terms of V an expression for the volume of vase A. So you're being asked to find an expression for the volume of vase A. Well, we know this volume scale factor, don't we? Because the volume scale factor will be the linear scale factor, 1.5, cubed. So the volume scale factor is 27/8. So in that case, the volume of vase A would be V divided by 27/8. And there is an expression in terms of V for the volume of vase A. And that is the answer. And that's the end of question 4. Question 5. A and B are similar vases. Vase A has a height of 10 and vase B has a height of 15. So the linear scale factor is 1.5. The difference between the volume of vase A and the volume of vase B, right, so we're going to be dealing with the volume here. Now the volume scale factor will be 1.5 cubed, 27/8. Okay, now the difference between the volume of vase A and the volume of vase B. So the volume of vase B, which is that number, subtract the volume of vase A, which is that number, has to equal 1197. So the yellow minus the blue, the volume of vase B minus the volume of vase A, is equal to 1197. It's just a question now of me finding an expression for that yellow and blue. Well, let's call the blue X, because we know then that the volume of vase B is 27/8 times X. And now let's substitute in these two expressions into this equation. We know that the volume of vase B, which is the yellow, 27/8 times X, subtract the volume of vase A, which is the blue, which is just X, equals 1197. Okay, now this is just an equation. It's got X's in it, it's got a fraction. Let's multiply everything by 8. 27x minus 8x equals, remember to times the right hand side by 8 as well, 9576. So on the left hand side now, we've got 27x minus 8x, so that's 19x equals 9576. So x is 9576 divided by 19. 504. So the volume of A, look, that X is 504. And what's the question ask us to do? Calculate the volume of vase A. I've done that. It's 504. Need to check in case the question was asking you for the volume of vase B, in which case you'd have to work it out now that you know X. But you don't need to do that. The volume of vase A is 504. Question 6. Well, the moment we see this one, we know it's going to be about similar shapes. So I'm going to have statue A, statue B, linear, area, volume. The volume of statue B is 20% less than the volume of statue A. That means the volume scale factor is 0.8, because to get from the volume of A to the volume of B, you have to multiply by 0.8, because the volume of B is 20% less than the volume of A. So the minute you know that, you can work out the linear scale factor, which is going to be the cube root of 0.8. So the linear scale factor is 0.928 and so on. And the area scale factor will be that number, the linear scale factor, squared. So the area scale factor is 0.86 to 2 decimal places. In fact, let's just do 0.8617. There we are. That's going to be loads of accuracy. So we worked out all our scale factors now. Now, what's the question asking us here? It's asking us, it's saying the surface area of statue B is k% less than the surface area of statue A. Well, I know to go from the surface area of A to the surface area of B, I know I multiply by 0.8617. So what percentage less is the surface area of B than A? The answer is, if you're multiplying by 0.8617, you're reducing by 13.8%. And so what percentage less is the surface area of B than the surface area of A? Answer 13.8% less. Tricky. And that is number 6. By the way, of course it was tricky. It's a question number 20. They're going to be tough towards the end of the paper. Question 7. Right. A and B are two similar vases. The vases are such that the surface area of vase B, that's the surface area of the smaller one, is 25/64 times the surface area of vase A. Right, so if I were to be going then from A to B, and if I were to be thinking about area, I know that the scale factor from A to B is 25/64, because I would multiply the surface area of A by 25/64 to get the surface area of B. So that means that I can work out the linear scale factor from A to B, the square root of 25/64, 5/8, and I can work out the volume scale factor from A to B, which will be 5/8 cubed, which is 125/512. Okay, now let's read the question, shall we? The volume of vase A, that's this number, subtract the volume of vase B, that's that number, equals that. Right, well, let's call the volume of vase A X, which means the volume of vase B is 125/512x. And now let's look at this equation here. It tells me the volume of vase A, that's the blue number, okay, which is X, minus the volume of vase B, which is this number here, 125/512, over 512 times x. So the volume of vase A minus the volume of vase B equals 541.8. Now there's an equation with x's in it that we can solve. Let's multiply everything by 512. Not forgetting to multiply the right-hand side by 512. Now let's look at the left-hand side there. You've got 512x minus 125x. So altogether you've got 387 x's. And that equals 277,401.6. So to work out x, I'm going to do 277,401.6 divided by 387. Gives me an x of 716.8. Now let's just go back to the question. What is it asking me to work out? Aha, look, it's asking me to calculate the volume of vase B. Is that x? No, x is the volume of vase A. So to work out the answer to the question, I need to work out the volume of vase B, which is 125 over 512 times x. So that's 125 over 512 times 716.8. So I work that out on my calculator, and I get the answer 175. So the volume of vase B is 175. And that is the solution for question 7. Question 8. Mathematically similar wooden blocks are made in a workshop. There are small blocks and there are large blocks. The volume of each small block is 300. Given that the surface area of each small block to the surface area of each large block is 25 to 36. Aha, so I know the area scale factor now. So to go from small to large, I'm multiplying by 36 over 25. Work out the volume of each large block. Well, I can work out the linear scale factor now. The linear scale factor will be the square root of the area scale factor. So I can work out the volume scale factor, which will be the linear scale factor, 6 over 5 cubed. So that will be 216 over 125. So now I can work out the volume of each large block. It will simply be 300 multiplied by the volume scale factor. Okay, 300 times 216 over 125 gives me an answer of 518.4. And that's question 8 done. Question 9. A statue and a model of the statue are mathematically similar, right? So model and statue. Right, the statue has a total surface area of 3,600. The model has a total surface area of 625. Oh, I can work out that scale factor in a minute. The volume of the model is 750. Work out the volume of the statue. Right. Well, the area scale factor is going to be 3,600 divided by 625. So the area scale factor is 144 over 25. So the linear scale factor is the square root of that, 12 over 5. And the volume scale factor will be 12 over 5 cubed, which is 1,728 over 125. So to work out the volume of the statue, I'm going to do the volume of the model multiplied by the volume scale factor to give me 10,368 cubic centimeters for my volume of the statue. Question 10. Now, this last question is quite demanding as it requires you to be fluent in your rules of indices as well. So let's have a look. Solid A is similar to solid B. Okay, here is some information. Look, I can immediately work out the area scale factor there. From B to A, 7776 divided by 486. So the area scale factor is 16. Okay, so the linear scale factor will be 4, and the volume scale factor will be 4 cubed, 64. Okay. Right, work out the height of solid B. So it's asked me to work out the height of solid B here, which would be 3 to the x divided by 4. But I really need to know what x is, don't I? So let's turn our attention to the volume here. I can see that 2 to the power of x plus 4 is equal, no it's not, I beg your pardon, I can see that 8 to the power of x, the volume of solid A, is equal to 64 times 2 to the power of x plus 4. Okay. Right, well, I need to solve that to find x. Solving equations with powers is always quite interesting. What we'll need to do is work in base 2 here. Now, 2 to the power of 6 is 64. So 8 to the power of x is equal to 2 to the power of 6 times 2 to the power of x plus 4. On the right-hand side there, I can add those two powers, can't I, when I multiply or add my indices. So 2 to the power of 6 times 2 to the power of x plus 4 is 2 to the power of x plus 10. I need to change this left-hand side into base 2. 8 is 2 cubed, so I've got 2 cubed to the power of x there, equals 2 to the power of x plus 10. Well, 2 cubed to the power of x is 2 to the power of 3x, and that equals 2 to the power of x plus 10. So I know that 3x equals x plus 10. Right, solve this equation for x. 2x equals 10, x equals 5. Okay, now come up here to the top. Now you know that 3 to the power of x here is 3 to the power of 5. So you know the height of solid A is 243. So I can write 243 here. So now can I find the height of solid B? Yes, I can. It's 243 divided by 4. Height of solid B, 243 divided by 4 gives me 60.75. And that was a tricky question 10. And that is the end of those IGCSE questions on similarity. Oh, wait a minute, where is it? There it is, question 10. Well done for making your way through those 10 questions. Do leave any questions or comments in the comments, and of course I'll respond, or just tell me how you're getting on with your maths if you haven't got a question. If you're preparing for your Edexcel IGCSE Maths, do subscribe to the channel. There's lots there to help you out. Thanks for watching. See you in the next film.